Okay, chapter 5, solving polynomial equations. We do everything by factoring. So we want to very first factor out the GCF. So that is the very first thing we're going to do. If there is no GCF, then we go back to, if it's two terms, we have the difference of squares, which factors into x minus, well, let's see, if we had x squared minus 4, that would be x minus 2 and x plus 2. The sum of cubes and the difference of cubes, these are your formulas down here. So if you didn't memorize it the first time we went through it, please write that at least 5 to 10 times so you know the formula. 3 terms, we're doing reverse FOIL, so that would be with Clinton Magic or writing the factors out. And 4 terms would be by grouping. So we're going to practice all of these. And then when we solve our factors, we are finding the x-intercepts, the solutions, the roots, or the zeros. Those all mean the same thing. So these examples. So if you can, if you know how to do this all by your lonesome, then pause it and please do these. If not, then listen up. So we want to figure out, these are cubes, and this is a sum of cubes. So my factors, my formula is going to be a plus b times a squared, opposite sign, minus ab plus b squared. And so I got to figure out what a and b are. So something cubed equals 64x cubed, and something cubed equals 125. So 4 times 4 times 4 is 64, and x times x times x is 4x. So this is my a. And my b, 5 times itself 3 times is 125, so this is my b. So now I'm just going to go back to the formula and plug these numbers in. So I have a plus b, so that's 4x plus 5. I'm going to square a, so 4x times 4x is 16x squared, so don't forget that 16. And then minus, I'm going to multiply 5 and 4x together and get negative 20x, and b squared is 25. All right, so now it says find the real number, real solution of the equation. This will give me an imaginary, so I'm just going to set this one equal. So I have 4x plus 5 equals 0. I subtract 5 from both sides. I get 4x equals negative 5. Divide by 4, and x is equal to negative 5/4. All right, so that is that. That's an x-intercept if I were to graph that. All right, the next one, again, so if you think you have the hang of it, pause it, do the second one by your lonesome. If not, what we're going to do, this is a difference of cubes, and I know it's a cubic because the x cubed. So my difference of cubes, the formula is a minus b, same sign, and then a squared, opposite sign, ab plus b squared. All right, but the very first thing I notice is we have a GCF. So I'm going to factor out that GCF. And we've got a common factor of 3, and then inside we have x cubed minus 8. So now I need to figure out what a and b is. So something cubed equals x cubed, and something cubed equals 8. And so hopefully you can come up with x and 2. All right, so I'm going to put x and 2. That's my a. X is a, b is 2. So my final answer, before I set one factor equal to 0, is my GCF of 3, and then my binomial factor is going to be x minus 2. My trinomial factor is going to be x squared. Multiply these two together to get 2x. And then square b, which is 2 squared is 4. Right? And that all equals 0. Okay? So this is going to be my real number solution. So I have 0 equals x minus 2. If I set 0 equals 3, 0 will never equal 3, so I throw that one away. But up here, I add 2 to both sides, and my real number solution is x equals 2. Okay. Okay, so here are polynomials in the quadratic form. So if you know how to do this, please pause it and just check your answers. But if you don't, let's see, we're looking for a difference that adds up to 0. So we have 16x to the 4th plus 0x squared, and then minus 1. So we're looking for something that multiplies to negative 16x squared, 16x to the 4th, that adds up to 0. Okay, so I have that, and I have that. So let's see. I think my answers are going to be 4 and 4. Right? One should be negative, one's positive. So if I reduce those, I get 4x squared over negative 1 and 4x squared over positive 1. And those would be my factors. If I write the factors, then I would have 1x squared and 16x squared. I would have 2x squared and 8x squared. And I would have 4x squared and 4x squared. And then this would be 1 and 1, right? And I have negative 1, so when I multiply, 1 has to be positive, 1's negative. And then here are my factors. So let's see, we have 4x squared minus 1 and 4x squared plus 1 either way. And those are equal to 0. So when I solve it, I have 4x squared is equal to 1. So I divide both sides by 4. X squared equals 1/4. And then I'm going to square root both sides. So I have x equals, and then I can split up the square root. So it's the square root of 1 over the square root of 4. So x is going to be equal to plus or minus 1/2. Right, so those are real solutions. This one is not going to be real, but we have 4x squared plus 1 equals 0. I'm going to subtract 1 and get 4x squared equals negative 1. Divide by 4. So I have x squared equals negative 1/4. So when I square root both sides of this, I have x equals plus or minus I times 1/2. Right? So those are my solutions. Okay. For this one up here, again, I can do Clinton magic or writing the factors. But I'm looking, let's see, I have x squared and x squared, 1 and 9, 2 and 3, or 3 and 3. And I need something that adds up to 6. Right? And so these would be it. So I have x squared plus 3 and x squared plus 3 equals 0. Right, so when I solve that, I have x squared plus 3 equals 0. I subtract 3. So x squared is going to be negative 3. When I square root both sides, I get x equals plus or minus I times the square root of 3. And that's going to be, I'll have 2 of those because this wouldn't be the same. Right, so these would not be x-intercepts if I were to graph this polynomial. Okay. Our next one is 4 terms, and I notice there's no greatest common factor, so I'm going to split them up into 2. Okay. So the first set, I notice 10x squared is the greatest common factor for the first 2, and then inside I get x plus 2. Okay. And you can double check that if you multiply it back in like that. All right, and then x plus 2 has no common factors, so I am just going to factor out a positive 1, and then inside will be x plus 2. All right, so notice I have a factor of x plus 2. I'm going to factor that out, and then I'm going to put 10x squared plus 1 together. And that is my factored form of grouping, and then I'm going to solve that. So I have x plus 2 equals 0, so when I subtract 2, x equals negative 2. So that would be one x-intercept. This one, 10x squared plus 1 equals 0, this is not going to be any real x-intercepts. I get 10x squared equals negative 1. I divide by 10. So I'm going to leave that alone because we're mostly interested in real solutions, because when we graph tomorrow, we're finding x-intercepts. Okay, and then we have this one. So find the zeros given a 0. So this is a 0. And this is 4 terms, but I notice they don't really, or they're not going to have anything in common. The first set, I could factor out an x squared. The second set, I could factor out a 3, but then it wouldn't match up. So I'm going to use synthetic division. So I'm going to put the negative 1 on the outside and the coefficients upstairs, and I don't need a placeholder. So I bring down the 1, I multiply and get negative 1, add to get positive 3, multiply again, 3 and negative 1. To get negative 3, I add them up and get negative 18. I multiply and get positive 18. And then this adds up to 0, which means negative 1 is a 0. And then it's 1 degree less, so this is 1x squared plus 3x minus 18 equals 0. And then I want to factor that and solve for my factors. So on this one, I'll do Clinton magic. So something that multiplies to negative 18 but adds up to 3. All right, so two numbers. So we have 1 and 18, we have 2 and 9. We also have 6 and 3, and it looks like 6 and 3 would work if this was a positive 6 and a negative 3. All right, so my factors are x plus 6 and x minus 3 equals 0. So when I set those factors equal to 0, right, I subtract 6 from both sides. So one of my x-intercepts is negative 6. I add 3 to both sides, and x is equal to 3. So if I were to graph this, my x-intercepts would be x equals 3, x equals negative 6, and the original one they gave me. So x is equal to negative 1, right? X cubed, and I have 3 x-intercepts. My y-intercept would be negative 18, but we'll get to that tomorrow. Right. The next one is find the zeros given a factor. It's the same idea. 4 terms. I don't really have anything in common that works with factor by grouping, so I'll use synthetic division. So I have x plus 5, so I want to use the opposite. If it's a factor, I'm going to use the opposite and solve for the 0. So if I subtract 5, the 0 is negative 5. So that's what I'm going to put on the outside with all my coefficients. So I have 2, 7, negative 35, and negative 100. I bring down the 2 and multiply to get negative 10. I add to get negative 3. I multiply and get positive 15. I add to get negative 20. I multiply to get 100. I add to get 0. So what I have left after I divided is 2x squared minus 3x minus 20 equals 0. So for Clinton magic, something that multiplies to negative 40 but adds up to negative 3, and you're putting 2x and 2x over here and figuring out what that is. If you use factors, you're writing 1x and 2x, and you're writing the factors of negative 20. So 1 and 20, 2 and 10, 4 and 5. All right, it's negative 20, so one of these has to be negative, and you're looking for something that adds up to negative 3. Okay, so that's going to be, this would be a positive 8. So we want that to be a negative 8. And x and 5 would be a positive 5. So when you add those up, you do get negative 3. And similarly, you could put 5 and negative 8, and then this one will reduce to 1 over negative 4. Okay, so I've got my other factors. So 2x and negative 4 have to hook up. So those go in opposite parentheses, and then I have x and a positive 5. And so this equals 0. So when I solve for my zeros or x-intercepts, I have 2x plus 5 equals 0. I also have x minus 4 equals 0. So when I get x by itself, I subtract 5. So I get 2x equals negative 5, divide by 2, and x equals negative 5 halves. Over here, when I add 4 to both sides, I get x equals 4. So my x-intercept is 4, negative 5 halves, and the original one of x equals negative 5. So I would graph all those x-intercepts. And the next one, write it down. We want to find the x-intercept of this equation. This has 5 terms, so we definitely can't factor by grouping. But they did give us a factor. So when I set that equal to 0, I get x equals 1. So I'm going to use that. So I'm going to put 1 on the outside and synthetically divide. So I have 2, 9, negative 12, negative 29, and 30. And if that is a 0, we should get 0 right here as our remainder. So I drop down the 2. I multiply 2 times 1 and get 2. I add and get 11. I multiply to get 11, I add to get negative 1, I multiply to get negative 1, I add to get negative 30, I multiply by 1, and then to get negative 30, and this does add up to 0. So my resulting cubic term would be 1 degree less, so 2x cubed plus 11x squared minus x minus 30. All right, and that's 4 terms, so technically I should be able to factor by grouping to find the other x-intercepts, but that's not going to work out, so we go to B. So it says provided that negative 5 is a 0 of your cubic term, so this is my cubic term, now find the x-intercepts. So what we're going to do is we're going to take our result from A, and we are going to synthetically divide that by negative 5. So I have 2, 11, negative 1, and negative 30. So that's the cubic term. And then I think we'll be able to factor. So I bring down the 2, multiply to get negative 10, add to get 1, multiply to get negative 5, add to get negative 6, multiply to get a positive 30, and that is 0. Consequently, negative 5 is also a 0 of our original function as well. Okay, so this is going to be 2x squared plus x minus 6 equals 0. Now, since it's a trinomial, we can factor that. Let's see, so we're looking for something that multiplies to negative 12, adds up to positive 1. We put 2x and 2x here. And then if you're doing it by writing the factors, we have 1x and 2x. 6 can multiply to 1 times 6 and 2 times 3, and you're looking for a difference of positive 1. Okay, so we have, let's see, 2x times 2 is 4, and that would be a positive, and then this would be a negative 3, and that would be a difference of 1. You could also do this, so you have negative 3 and positive 4, and this reduces to x over 2. Right, so when we write our factors, we have x has to get hooked up with the negative 3, so that's an opposite parentheses, and then 2x and 2, and that's a positive. So when I factor these, or solve them, I have x plus 2 equals 0, so I have x equals negative 2. And then 2x minus 3 equals 0, so I add 3 to both sides. And then I divide by 2, so x is equal to 3 halves. All right, so all of my x-intercepts for my original function, let's see, we have x equals negative 2, x equals 3 halves, x equals negative 5, and x equals 1. So all of these are x-intercepts for my original function, right? Similar to the problem on your Chapter 5 test. And that is the end of the lesson, and I will see you guys tomorrow.